there's one more addition we're going to make to our warmer, colder game. It's actually a pretty big change. Instead of moving north, south, east, or west, we're going to be able to move at any angle that we want to move to. So I'm going to create a new function inside the coordinate object. And I'm just going to call it move. And now I have to say self because it belongs to this object. And I'm going to pass in an angle and a distance that we're going to move along that angle. Now, if you've taken geometry, you may have seen sine and cosine used to find like the adjacent or opposite sides of a triangle. Sine and cosine are really useful for separating out the amount that we're going to move in the x direction and the amount we're going to move in the y direction if we want to move along a particular angle. So if we want to move at an angle theta from our current position at the bottom left of this triangle, basically we want to move along the hypotenuse. The way we're going to simulate that is we're going to change our x value by the adjacent length and our y value by the opposite length. And then we're going to end up with our coordinate right here. So the way to do that is self.x equals self.x plus, and then we're going to add in the cosine of our angle times the distance. So we're going to multiply by this distance that we want to move. And this distance right here is going to be the length of the hypotenuse. We're going to do a very similar thing for the y values, except that we're going to move with the sine of the angle rather than the cosine. Now, we're going to have to change our user input to use this move function. So let's scroll down to where we were saying like north, south, east, or west. And now we're going to have to ask for angles and distances. So let's delete this. I'm going to paste in a call to move. Now it's going to be start.move, and we're going to get rid of the self here, because that self that I just deleted refers to whatever object I'm calling. I could move my goal, but like I said before, I want to move the start and keep the goal in a particular location. So let's ask the user for an angle, and probably they might give it as a decimal, I don't know, so I'm going to convert it to a float. So I'm going to just say give angle and assume they know what that means. And I'm going to do a very similar thing for the distance. I'm going to say distance equals give distance. Now, an important thing to note is that cosine and sine in the math library, they use an angle in radians. So people are usually more familiar with degrees, where we go 90 degrees is a right angle, 180 is basically the opposite as the direction we were facing, and then we can go all the way around to 360. However, the sine and cosine functions that Python uses deal in radians, where there are 2 pi radians all the way around the circle. So 2 pi is the same as 360, or 0. Pi is the same as 180, and pi over 2 is the same as 90. So we would like to convert from one to the other. We'd like to convert from one to the other so that our user can type in an angle in degrees. So give angle in degrees, we'll even clarify that. And now we need to convert it. So let's name our new variable radians. And the conversion is, so you notice how I said that 360 degrees is the same as 2 pi radians. So what we can do is we can take the angle in degrees and we can multiply by 2 times pi, 2 pi radians, divided by 360. So this is our conversion factor that will change degrees to radians. Now this can actually be simplified a little bit. You might notice that there's a 2 in the numerator of this fraction right here, and there's a 360 in the denominator, and those are both, of course, divisible by 2. So I can delete the 2 and divide this by 2. I'm basically just simplifying the fraction. And this is what you'll typically see. You'll typically see multiplication by math.pi over 180. So now I've got something in radians, and I can pass that in instead of degrees. All right, so these lines of code right here should do what I want, and I'll still have moved a little bit. Now, the downside is it's going to be a lot harder to get a precise location. It's going to be harder to actually go to the exact location of the goal. So I would like a new variable that is called close enough. So close enough. And I'm going to start close enough as 1. Just 1.0 is going to be close enough that will decide we've reached our goal if we're one distance away. So instead of recent distance greater than 0, it's going to be recent distance greater than close enough. And the other thing that I would like to do is I would like to print out my x and y locations. So I'm going to go back up to coordinate. Now I could write down here just a print start.x, comma, start.y, but I'm actually going to write that up here, and I'm just going to name it print self. And I'm going to write the exact same code that I was just saying below. And I actually want to put, I want to see a comma on the screen, so I'm also going to put that in. So if I ask start to print, it's going to print its own x and y value. So let's go ahead and do that right here. So I can say start.print, and since I have the dot and the start here, Python knows that I'm calling the print that belongs to start. I'm not calling some other print statement. I'm not calling our traditional print statement. This is a special print statement that belongs to an object of type coordinate, which start is. So it's going to call this one right here. Let's go ahead and run our program. So give an angle in degrees. I'm going to move it a 45-degree angle. I'm going to head towards the middle of my 0 to 10 interval in the first quadrant. I'm going to move a distance of 5. That doesn't actually put me at the coordinate 5, 5 because I'm moving only at a 45-degree angle along the hypotenuse, but it's going to head me in that direction. All right, I got warmer. Well, if I got warmer, I might as well head further in that direction. Let's move 5 more. And you can see my location being printed on the screen. I had 3.5, 3.5 as my xy. Now I have 7, 7. All right, it looks like I went too far. So I'm going to head back. Now if I add 45 degrees to 180, I will head directly in the opposite direction I was in before. I'm not going to move as far this time. I'm just going to move a distance of 3. All right, that got me even warmer. Now I'm really not sure exactly which way to go. I'm going to try to move at an angle of 135. So this is basically up and to the left. And I'm going to move just a short distance. I'm just going to move 2. Okay, that got me closer. Great. Well, I'm going to keep heading in that direction, 135 degrees, so up and to the left. And I'll move a distance of 2 again. Okay, I went too far. So I want to move now down and to the right, back where I came from. Now, if I put in negative 45 degrees, I'll basically have rotated down and to the right. I'm sorry, I'll have rotated from facing to the right to facing more down. And let's move just a distance of 1 and see how that gets us. Okay, a little bit closer even. I'm really a little bit unsure which direction to go now. I'm going to move in that negative 45 again, just by a distance of 1. So I'm going to try and shrink how far I'm moving and get a little bit closer. All right, so that didn't work for me. So let's revert back. Let's move just a half in the better direction. Okay, that got me warmer. Let's try to move back towards down and to the left again. So 225 degrees. And I could put in other values. I'm just trying to use values that I'm sort of comfortable with, that I can sort of picture in my head a little bit. All right, that got me even warmer. Cool. So I'm going to keep moving in that direction. And I got close enough. Success. I got close enough to the goal. Awesome. Now, I know that's a really hard thing to visualize, but the key point of this is how easy it is to modify our program once we have a nice class set up and we're using these objects, right? So I added in this new move function that took an angle and a distance, and all I had to change about this whole program was a couple lines right in here getting the angle and the distance, and everything else worked just as it should. This is another example of something called encapsulation, where we hide or put in a capsule any sort of complexity that we're dealing with. So the complexity of movement is all encapsulated in this move function right here. And once we get it working, we can call it in our code by using its name and passing in the arguments without really worrying about the details of how the move is taking place.